This video will go over expanding and condensing logarithms. We're going to begin by looking at some properties of logarithms. First, when we have the logarithm of a product, we can separate that into two logarithms with addition. When we have a logarithm of division, we can separate that into two logarithms with subtraction. And when we have the logarithm of an exponent, we can separate out that exponent by pulling it out front. The way that I remember this is I think about my name. The N stands for nothing, the A for add or subtract, the M for multiply, divide, and the E for exponent. If we want to expand, we're adding in logarithms and we're going up. So an exponent becomes multiplication, multiplication expands to addition, division expands to subtraction. And if you already have addition, subtraction, you don't do anything to them. If we're going to condense, we are going to be removing logarithms. If we have addition, that becomes multiplication, subtraction becomes division, and multiplication becomes an exponent. Let's look at what this looks like. Here, we are going to expand this logarithm, so we're going up our name there. Notice that here inside the parentheses, the 4 is only on the z, right, not the x. So before I can handle that power, I need to separate the multiplication. And we separate multiplication or expand it using addition. So here's what our next step would look like. Once we've done that, now the fourth power is only on the z, and I can expand the exponent using multiplication. And that's it. Let's look at this one. We are expanding. Again, we're going up our name there, and we start out with division, and we expand division using subtraction. And once we have that subtraction done, we need to handle the exponent. Piece of cake, right? Well, let's look at what happens when they get a little bit more complicated. Sorry about that. You got a little sneak peek, didn't you? So this is a little bit more complicated. We are still going to expand, so we're going to go up. Notice that the numerator and denominator are definitely distinct, right? We don't have a power or anything happening to both pieces. So the first thing that we'll do is we'll split the division into two logarithms using subtraction. Okay. Now from here on out, you can do multiple steps at the same time, as many as you're comfortable with, but for our purposes, I'm just going to do one piece at a time. We're going to handle this first logarithm here. I want to remind you that this is a cubed root, and remember a cubed root would be the same thing as the 1/3 power. So I can pull that exponent out using multiplication. And then now I have the 5th power, and again I can pull that exponent out using multiplication. Now we're going to focus on this second logarithm here. Notice that much like that first example we did, the 4 is only on the z, not the y, so I need to break these two apart, and we break multiplication apart with addition. So I added in a new logarithm. Notice I put brackets around this. The reason I did that is that this is subtraction, so we're going to have to distribute that in a little bit. If this had been addition, it would have been fine. Now our logarithm for y is fine. We have to deal with our z to the 4th, and we pull the exponent out using multiplication, and then we'll distribute that negative symbol. Let's look at one more expansion. So we're expanding. Again, we have a pretty distinct numerator and denominator, and I say that because that whole thing isn't to a power or a root or anything like that. So we'll split apart the division using subtraction. And then just like that last problem, we'll handle each piece separately. For the first part, we can pull the 7 out using multiplication. Now, over here on the right, we have something a little bit more complicated. We have the cubed root of the y squared z. That cubed root is on both the y and the z, so I have to pull that root out first. And remember, the third root would be the same thing as the 1/3 power. So I pulled that 1/3 out. Now I'm ready to split up the y squared z, and we split up multiplication using addition. But notice this 1/3 stayed out front and our negative, right? Because this negative 1/3 goes for this whole thing here. So we have to be sure that we keep it out front. And we put brackets, excuse me. Now we're ready to pull out the 2, the exponent, and then we can distribute. Oh, I might have did a little fib. Here we go. We're going to do one more expansion. Sorry. So again, we're expanding, we're going up our name, but this one has the situation where everything in here is the cubed root. So we're going to have to take care of that root first by pulling the exponent out. So that 1/3 will remain in front for all the rest of our operations. Now that we've taken the root taken care of the root, we'll handle the division next. So we split it up with division. Now we can deal with this first logarithm here, and we can split this up using addition. And then we can pull the 4 out front. And then, oh, I'm sorry, I did the z at the same time, right? Pulled that 2 out front there. Notice that this 1/3 stayed the whole time. And then I would go ahead and distribute it. We have 2 more examples, and these 2 are condensing. So here we're going to write this as a single logarithm, which is usually the instructions, and what that means is condense. So for expansion, we were adding in logarithms. Here we're going to take logarithms away. So we're going the opposite direction. And it's important to note that you can only combine if they have the same base. So notice all of these logarithms have base c. If one of those had had a different base, we would not be able to combine it. Let's look at, we have some powers here first, right? We have a 4 out front, and we have a 1/2 and a 6. So those are multiplication. They become exponents. So there's the 4th power, the root, and the 6th power. Now we can just go left to right. Here I have subtraction. Subtraction becomes division. There we go. And then we have addition left, and addition, it becomes multiplication. And remember, when you multiply, it's just like you're multiplying a fraction, right? So you would have numerator, numerator, denominator, denominator if you had a denominator over here. Don't let that part kind of freak you out. Last one. Again, we are going to condense, so we're traveling down here. Again, just like the last one, we have a power and a root. So I'll go ahead and handle those, and they become exponents. And then here we have addition, and addition condenses with multiplication. So there we go. A lot of times condensing is actually less rigorous than expansion. I hope you found this helpful. Good luck.